A lot of times I get questions on HCF and LCM using easy way to do it. So in this video, I'm going to make it very easy for you. And let's try to find HCF and LCM of two numbers using prime factorization and factor tree. Let's get started. Now, don't forget to like the video. Let's get started. Now let's take two numbers, very simple way. So I want to find HCF and LCM of 24 and 40. I want to find LCM and HCF of these two. Now how to do it using prime factor tree is start dividing the numbers with the smallest prime number, which is 2. So now we're going to form a prime factor tree now. So now first let's divide with 2. So 2 12 is 24, and again divide with 2. 2 6 is 12. Now again I can divide it with 2. So 2 3 is 6. Now I got the prime factors 2 into 2 into 2 into 3, that I get 24. Now let's do the same for 40 as well. Let's see now. So now let's start with the smallest prime, which is 2. So I'm going to write here 2, and 2 20 is 40. Again let's do with 2. So 2 10s are 20. Again let's do it with 2. 2 5s are 10. Now we got the prime factors for 40 as well, right? So now 24 can be written as 2 cube into 3. Now let's write this. So I'm going to write this here. 24 can be written as 2 cube into, so we got here 2 cube into 3 power 1. Now the next one is 40. So 40 can be written as 2 cube into 5 power 1. 2 cube into 5 power 1. Okay, now we got the prime factors. So this is called prime factors here. So 2 and 3. So we've written in prime factorization format. Now we need to find HCF and LCM. Now for HCF, let's make it very easy. Let's see this now. So I'm going to tell it using for HCF. So for HCF, you have to take the common factors with least power. Now in this case, 2 cube into 3 power 1, 2 cube into 5 power 1, the common factors are just this one, 2 cube, and both are having same power. So you need to consider the common one. So in the next example, I'll give one more example which will make you to understand better. But now here 2 cube is common. So now I'm going to write here 2 cube, and we don't have anything else common. So HCF is 2 cube, which is 8. So 8 is the highest common factor which divides both. 8 3s are 24, 8 5s are 40. So 8 is HCF. Now LCM. Now for LCM, you have to consider the highest power factors here. So the two highest power factor here and here we have same anyway. So 2 cube into 3 power 1. So you have to consider all, not just common. For LCM, you have to consider all factors with the highest power. So in this case, 2 cube, we consider only once. Now 3 power 1, here we don't have 3 power 1, so that's I guess 3 power 1. Into, here we have 5 power 1, so 5 power 1. So this is the LCM. So I'll give one more example so that you'll be very clear with it. Let's see now. So I'm going to write here, so LCM is 8 3s are 24, 24 5s are 120. So 120 is the LCM, so least common multiple. So if you see here, so 24 5s are 120 and 40 3s are 120. So we got this. So HCF of 24 and 40 is 8. LCM of 24 and 40 is 120. Now let's do one more example so that you'll be very clear. Let's see now. Now I'll take one more example so that you'll understand very easily. So that let's see now. So I'll take this time. I'm going to take 24 and 84. Let's see now. So I'm going to take 24 and 84. Now you'll understand very easily. So let's do this. Now first we'll do prime factors. Now 24 prime factors is, again let's do with 2, and here it's 12. Already we did it 2 once again. 2 6 are 12. Again divide with 2. 2 3s are 6. Now we got the factor tree, and 2 cube into 3 power 1. Now let's do for 84. Now I'm going to write here 2. And 2 42s are 84. Again, let's do it 2 21s. Now again, 21 will not go with 2. Let's try with 3. So 3, and this is 7. So that's it. So we are done with 2 square into 3 into 7. We are done with 84. So let's write that in prime factorization format. Now let's see this. Now first what I'm going to do is, so I'm going to write here 24. So 24, we can write it as 2 cube into 3 power 1. And 84, we can write it as 2 square into 3 into 3 power 1 into 7 power 1. Okay. Now we need to find HCF and LCM. Remember, for HCF, you have to take common and least power. Now let's see this. Now for HCF, what we have to do is, for HCF, you only need to consider the common prime factors. So you should not consider the factors which are not there in both common and least power. Now here, common is 2 is common here. So least power is 2 square. So 2 square into, now 3 power 1, 3 is common, and least power anyway 1. So 3 power 1. So that can be written as 2 square into 4, 4 3 is 12. So 12 is the highest common factor for these two numbers. So 12 2s are 24, 12 8s. Okay, 12 7s are. Okay, so anyway, let's come back. 12 7s are 84. Next, now what we are going to do is we need to find LCM. Now for LCM, what we have to do is you need to consider all the factors with highest power. If it is common, consider highest power. If it's not common, take it as it is. Now let's see this. Now here 2 is common prime factor here, so consider the highest. If it is common, consider the highest. If it is not common, just take as it is. Now here it is common, so highest is 2 cubes, so I have to take 2 cube into 3 is common, so I'll just take 1, 3 power 1 into 7 is not common, but still you need to take highest of it, which is 7. So now this will become 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 into 7. So now 24 into 7, let's find it. 7 4s are 28, 2 here, 14, 15, 16. So 168 is the LCM of these two numbers, 168. Okay, now let's find out. So highest common factor, 12 divides both the numbers, 2 2s are 24 and 12 7s are 84. And 168 LCM, so 24 divides 168. If we take 24 5s are 120, 24 6s are 120, and 24 7s. So this will be 24 7s, and this will be 84 into 2, 168. So we got LCM and HCF of these two numbers as well. I hope you are clear with this. Go through this once again. If you're not clear, do add in the comment section if you have any questions. I'll be more than happy to do other video, and do subscribe for more interesting videos. Thank you.